Alright, hello everyone. My name is Brent, and this is going to be the first episode of Wolfenstein game programming. So, what we're going to focus on for this series is the Wolfenstein ray casting engine. So, I have a little demo here of a project I made about 2 years ago. This is using all Java. I have the same project here in lightweight Java game library, which I'll show next. But this is just a preview of what we're going to be doing for this series. So let me take this out, set the volumes up. Just going to play this. So this is the basic idea, right? If any of you have played Wolfenstein 3D, you know what's going on here. So we can shoot. This is the basics of what I came up with 2 years ago. Then I abandoned the project for lightweight Java game library, because I didn't realize that my code was so awful that I was the reason I couldn't play the game in terms of speed. So what I did instead was ported it to lightweight Java game library. So we're just going to play this one real quick. See if this shows up. Alright, let's turn this down a little so that you can hear me talk. So this is the basics of what we have. We got a little fisheye going on here. Something wrong with the protection. So we can shoot at enemies, they can die. We got health up here, some experience points. We have inset doors, can't open it because I don't have the key, right? So this is the base idea of what we're doing. So if you know anything about the Wolfenstein raycasting engine, you can just Google it real quick. Engine, Wolfenstein 3D engine. Probably make it come up. Yeah, there we go. So if you know anything about Wolfenstein 3D, the game's 3D isn't real 3D, called pseudo 3D. It's built on this 2D layout here. So you have a basically a 2D array of pixels, and you have a pixel in the center which denotes where you are. And as you look around, you use some complex mathematics to display this pseudo 3D reality, right? So this is what we're going to focus on for this episode. So I'm just going to close this real quick, and we're going to get started by just setting up our project initially. So we're going to call this let's just call this Wolfenstein 3D clone, right? Because we're making a clone of Wolfenstein. We probably won't make it look exactly like it. I mean, we could if you want to. So we'll see how it plays out. But we'll probably just end up making our own game, something a little bit more complex or a little bit more interesting looking in terms of visuals. So we're going to open this up, and in our source folder, we're going to make a class. So if you're new to Java, go look at some different tutorials, because although I will be explaining things, I'm not going to explain the most fundamental things like what a class is, right? So I'm just going to call this driver. That's the naming convention I used in college. So this is the class that's going to hold our main method. Get rid of this. So our public class, this driver class, is going to extend a canvas. What the canvas is a Java AWT component, which allows us to draw. It has specific functionality that allows us to draw on the canvas. And then we're going to implement runnable. And this is saying that our class is going to have a thread in it which will handle all of our operations. So it's telling us about unimplemented methods. We'll get to that later. So we're going to first start in the main method, right? We want something to display this canvas in. So we created this container that lets us draw on it, right? But we need to actually create a window to hold this container. So what we do is create a JFrame. Just call it frame. Give it a title. So we'll call it Wolfenstein 3D clone. And then we're going to need to import JFrame. And then JFrame has some methods to it that help us modify the frame. So first we're going to do frame dot set size, and we're going to use let's say 600 by 400 is a good size. Frame dot set default operation. This is the default close operation, so we're going to say exit on close. So when we press the little button at the top, it's going to completely quit the program. If you don't put this when you exit at the top, you'll notice that this button's still red, which is saying that the program is still running, right? What else do we need? Set resizable. We don't want to have to deal with that. That's pretty complex mathematics to modify our. Actually, it's not that complex, but we don't want to deal with that. Set location. So we want to set where our frame opens up. So whether we want it in the center of the screen, whether we want it in the corner, stuff like that, you can specify here. And then finally, set visible, right? We want to make our frame visible. So let's just add this unimplemented method so that we can run this. We'll switch this. I like to have my main method at the end. So here's our run method. We'll get into that later. It's telling us about a default serial version ID. This is a very specific ID for when you're trying to make your classes serializable. This doesn't matter to us, but it'll give us a warning if we don't use one. So we'll just use the default. So if we run this, this should show up a frame. See, here we go. We got our blank frame, nothing in it, but we have this canvas here that we need to add to this frame so that we can draw in this canvas, right? So what we're going to do is create a new driver object. Let's call it game. So we're going to create this game object, and it's going to have a set of information in this game object that allows us to draw, and then that game object will be added to this frame, which is the container that holds this drawable canvas. So what we want to do is, after we create the frame dot, actually we'll do it after we set the size. So frame dot add, so we're going to add a component, which is our game. So we're adding this canvas to our frame. So let's see, what else do we need? So this isn't going to do anything if we run it, right? There's no information in this driver class that displays color yet, or texture objects, stuff like that. So we don't have any of that yet. So what we're going to do is create a constructor, and this constructor, since we're extending canvas, so you can do dot and see all the different methods that we have access to. So the one we want is dot set preferred size. So we're going to set the size of our canvas to match up with the size of our frame. So I'm just going to do 600 by 400. I think you need to use dimension. Yeah, so we have to create a dimension object. Oops. So new dimension 600 by 400. Then we'll import this. And then we want set minimum size so that there's no ambiguity to the program. It might have its other specific things that it wants to do, but we're going to make sure that this canvas size is this canvas size, right? So this isn't going to do anything either, right? If we run this, all we have is a 600 by 400 canvas that has been added to this J-frame. So we want to start drawing stuff to the screen, right? So we're going to make this void method start. Actually, we could probably make it private. That has to be public. So in our start method, what we want is we want to create a thread that will let us run this. So we're going to come in here and create a new thread. We're just going to call this thread. So in the start method, we're going to do new thread. So we're creating a new thread, and we're going to do thread.run. And what this does is it lets us run this method. So this isn't going to do anything either, right? Just going to do incremental approaches, right? Nothing's happening. But we're going to get to that. Now that we're in the run method, right, this is where we're going to do our rendering and updating. So how do you do rendering and updating? You run a loop. So while true, obviously this isn't the best method. We should probably just do we'll just leave it like this for now. It doesn't matter. If you break out of this loop, you basically ended the game, right? So we'll just do system.exit throughout the rest of the code if we want to exit the game, right? So in this method, we have render and we have update. So right here, this would be graphics, rendering to screen. This here would be like mechanics, movement, and timing information. So this right here, your render, handles actually drawing pixels to the screen. The update handles you walking around in the game, like music, enemy movement, door logic, stuff like that. So we're gonna implement these two methods. What am I doing? Public void render. So this will handle our rendering. Void update. So we're not gonna do anything with the update yet. We don't have any, graphics on the screen to actually have a reason to update. So we're just gonna start with the render method. So we want a buffer strategy. What is it, like get buffer strategy? Oh yeah, there we go. Did I spell this wrong? Is it just buffer strategy? Oh yeah, it is. So this returns a buffer from our canvas that we can use to draw on. So our canvas has a set of properties, like I explained before, a set of fields and methods. So we want to return the drawable component of our canvas right here, so that we can start drawing on it. So then we're going to check if BS is equal to null. If it is, we're going to create our buffer strategy. So this is saying if we don't have a buffer strategy to the canvas, we're going to create one. So when you start, generally you need to create a new one. And then we're going to do return, because we want to break out of this. We only want to create one if we don't have one, right? If we already have one, don't create one. And then we need a graphics component G. I'm actually going to put this up top, bs.get draw graphics. I'll explain this in a second, hold on. So up here, I'm going to put the graphics object. So this is an object that has a lot of functionality that lets us draw things. So we're going to take this buffer strategy, this container for drawing, and we're going to get the draw graphics. So the specific object, graphics object, that lets us perform very important functions. So if you look through here, like we have like draw 3D rectangle, draw an arc, draw an image. This will be really important. We have things like fill a rectangle, fill a polygon. All right, get color. There's set color, set clip. All these things that we need. So let's see, what does it BS show? So once we're done drawing to this buffer strategy, we're going to want to show it. G is disposing. What does this dispose to? Okay, well, self-explanatory. Basically releasing any system resources and disposing of the graphics. But this is the important one. This lets us show the information that we've show the information that we're trying to render, right? So we'll do something like set color. So we'll do color dot gray. Set color dot black, and then we're gonna have G dot fill rectangle, and I'll explain these in a second. I'm just going through them. So this starts at 0. Actually, I'm gonna go up here and make variables for the width and the height. Private int width, private static final int. We're not going to change these at all. Width equals 600. Private static equals 400. Right. So now we have our width and height. So I'll just change all these real quick. Anywhere else? I gotta import this. Come on. We'll leave this alone. This is fine. Okay, let's see. So if I go, let me just fill these in, because I won't be able to run the other project. So the entire width, this is height divided by 2, height divided by 2, this is width, this is height divided by 2, and this is 0. Now let's run this. I'll explain this in a second, don't worry. It's not working. Oh. Error. Component must have a valid peer. Do public void start. Then we'll do game.start. Errors on my first video. What's going on here? Oh, okay, here we go. Alright, so this is what we drew to the screen. We have half of it is gray and the other half is black, right? So let me just go back into this one. Let's turn off the volume. So if I play this one, right, you'll notice that the floor is a darker color. The floor is a darker color than the ceiling is. So this is basically how the Wolfenstein engine works. You basically just split in the center, because all of our graphics are going to be drawn to a horizon line, which is the center. So you'll never have to worry about where they touch, right? So you're going to render a color to the top, and then render a color to the bottom, and this will make it look like there's a ceiling and floor, right? Now we'll change this later on to modify this so that we can actually render tiles to the ceiling and tiles to the floor. This is a bit more complex. And one of the things that wasn't done in Wolfenstein 3D, I don't know specifically if it could have handled adding more textures. So let me go back and explain this. So we got our draw graphics, right? And we're setting the color. Let me pull it up. We're setting the color to be gray. And then we're filling our rectangle in our canvas. This is the starting point, X, so we're starting here. For width-wise, we're starting here at 0. We're also starting at 0 Y-wise, so we're starting in the top left corner. And we're saying we want to fill a rectangle that is width, that is as long as our width variable, and our width variable is 600, but only half the height of our height variable, so height divided by 2. And then we're going to set the color to be black, and then we're going to start all the way on the left. Alright, so we're going to start then we set the color to be black, and then we're going to fill a rectangle for the bottom half. So we're going to start all the way to the left for X, so 0, but we're going to start halfway for Y, so height divided by 2. The width of our filled rectangle is going to be width, which is 600, but the height is only going to be height divided by 2. So this is how we get this half and half look. So we get half gray, half black, and you can change this to whatever color you want, right? Let's see, anything else I want to do for this video? We'll talk about the game loop in another video. I don't want to get into it because it's pretty off-putting to start a video with, and it's not really necessary until we get into updating. So we're just going to worry about drawing as quickly as we can, and then we'll cap it. So let me just go over this code real quick, explain it. Alright, so we created a class that extends a canvas so that we can draw on, and it implements a thread. We have our thread here and our graphics. This lets us draw specific methods to this graphic object that lets us do what we want to do. We create a width and a height variable. We create a constructor for our class, and we set the size of this canvas, our class driver. We create this start method that runs this loop, this thread, and we want to loop forever until the game's finished, right? We want to keep rendering and keep updating. So in this render method, we got the buffer strategy, which is the drawable container. If it's equal to null, we want to create a new buffer strategy, and then we want to get the graphics component of that buffer strategy so we can actually specifically draw using the graphics methods. Then we want to dispose, free up resources, and then finally show using our buffer strategy. Then we didn't do anything with this update method, but we we created it for later. And then finally we have our main method, which actually runs our game. So we create a JFrame component, then we instantiate our game, our driver class. We create a size for the frame. We add our game component to this container. This is just a frame. Let me go over this. This is just a frame that holds components. Our frame is just the window, the outside bar, right? We need to add an actual container inside of that that lets us draw graphics. So that's why we're adding our driver class to the frame. Set the default close operation. Don't want to resize. We set the location relative to the center, and then we set it visible. After we've added our game component to the frame, then we could start the game, and that draws what we have so far on the screen. So that's it for this episode. If you want to look again at what we have here, I'll just let this run one more time. So this is what we're going to be doing. In this series, we're going to get more complex because I stopped this one early, but the lightweight Java game library one is complete. So we're going to get into like AI, collision. It's pretty bad collision in this one. Lets you get a little too close. UI, so like all this stuff, switching between weapons, right? Animation, all that good stuff. We'll be getting into that. So thanks for watching. We'll get to probably starting the actual raycasting portion of the game in the next episode. So we'll be trying to set up the mathematics for drawing the walls. So thank you for watching.